Yes, so we are going to start with the topic sequences, which we started yesterday. So, as I told you yesterday, I'll be taking up your doubts at the end of the lecture. So, let me just start with sequences. So, what we did was we defined what is a sequence. I told you that there are always three ways with which you should be addressing anything, what it is, why we need to study this, and how we are going to do that. So, what it is precisely clear that we discuss that sequence is an ordered list of objects. Yes. So what we are already done with the what part, and I introduced the notation in front of you that we define the sequences like that we have the general term an. Like I gave you the example. For example, you have a sequence 1, 2, 3, 4, 5, 6. So that is the sequence of natural numbers. So we'll just take it up like an equals to n. This is going to be the nth term or the general term, right? And if you have another sequence, say 3, 6, 9, 12, so this is going to be a sequence of multiples of 3. So you have all the multiples of 3 arranged in an order. So the general term of the sequence turns out to be 3 into n. So that is the general term. So I told you the notation of this. We denote the general term of the sequence by an. So n is in the subscript. So that's how this works like that. So now if we talk about how do you denote a sequence, right? So for that, we have the notation an enclosed in triangular brackets. You can use this notation, or you can use the notation an enclosed in curly braces. So you have the sequences defined in this way. In your textbook, you will be most of the times finding this notation, right? So I hope the difference is clear. If you write simply an, right, if you write simply an, so that is the term, nth term. But if you enclose this an in brackets or curly braces, so that means you are denoting the sequence. So we will be using this notation to denote a sequence, right? So from this point onwards, you will be clear whenever I'm going to use this notation that I am referring to a sequence. So that is the clear meaning of what is a sequence. We discussed that yesterday. Now, so let me address the next topic which we are going to take. So that is connected with what is a sequence and how we define it. So now we are going to address the how part, how we are going to define a sequence. So the first way which we are going to use is the same which we just discussed. And the next way is recursively defining a sequence. So through recursive definition, we can define a sequence. I'll be just starting with an example, so it will be clear to you the meaning of the word recursive. So let's take a very simple example. For example, you have A1 is 1 and AN is n into AN minus 1, right? So in when you are going to define a sequence recursively using these kind of formulas, so that is called a recursive definition. That means the nth term of the sequence is defined in terms of the previous terms. Previous means n minus 1th term, or it can be even more than that. It can also be in terms of the previous 2 terms or previous 3 terms. So this is what we mean by recursive definition, that a particular term is defined in terms of the previous terms. So whatever can be the formula, that depends upon the particular sequence we are working on. But this is one example, right? So obviously, if you look at this way of defining the sequence, so if I substitute n equals to 2, then in this, because now I'm interested in looking at the terms of this sequence. So if I put n equals to 2, so you see A2 is 2 times A1. So that means to get the value of A2, I need to know the value of A1. So मेरे पास A1 का value होना चाहिए. That is why it is 2 into 1, which is 2. So that means this is mandatory to be given here. That information is necessary to be supplied whenever we are defining a sequence in a recursive way, right? So I just hope that is clear, that whenever a sequence is defined in this way, the nth term is expressed in terms of the n minus 1th term or the previous terms using any elementary operations, multiplication or division or addition, subtraction. So we say the sequence has been defined recursively. That means instead of giving a general term just like that, this example, we are now defining it in this way. This is called recursive way of defining. So let's just look at another example of the same thing. So say you have A1 equals to 1, A2 equals to 1. So here I'm giving you the two initial terms, A1 equals to 1 and A2 equals to 1. And the formula is an plus 1 is an plus an minus 1, where n will be obviously starting from 2, greater than equals to 2, because the moment you put 2 here, so this will be A3 will be A2 plus A1 when you put n equals to 2. So the value of A3 will be 1 plus 1, because you are given the values of A1 and A2. So this is 2, right? So similarly, you can evaluate the other terms of the sequence. For example, I'll write here, if you want to compute A4, so A4 will be A3 plus A2. So as you can see, any term of the sequence is just the sum of the previous two terms, one previous term and one even before that. So A4 will be A3 plus A2, A5 will be A4 plus A3. So you just substitute the values, you will get the terms. So A4 is A3, A3 we have just evaluated, which is 2, and A2 was given to us 1, so 2 plus 1 is 3. A5 will be 3 plus 2 will be 5. So this way you can see what particular sequence you are getting here. If I write the complete sequence, so it's 1, 1, 2, 3, 5, and obviously the next term is going to be 5 plus 3, 8. So because any term is a sum of previous two terms. So 5 plus 8 is 13, 13 plus 8 is 21, 21 plus 13 is 34. So you just keep on evaluating the terms and get the sequence. So we get this sequence 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on. So if you are able to figure out yet what this sequence is, this is a famous sequence which is Fibonacci sequence, right? So this was discovered by the mathematician Fibonacci many centuries back. So it has many applications in engineering, in finance, in physical systems. In physics, it has many applications. In fact, these are the general applications of the sequences and series, but this Fibonacci experience sequence particularly find its applications in nature. So to understand, if we get an understanding of this sequence, we can understand many laws going on in nature, and particularly recently its application has been found in finance using the concept of golden ratio. So you just search all these terms, you will be finding very interesting explanations on them. Directly, it's not a part of our syllabus, but it's something connected with the Fibonacci sequence. So golden ratio is basically the ratio of the two terms, consecutive terms of a sequence. For example, you just do 13 by 8, 21 by 13, 34 by 21. So you can take consecutive ratios. So you will be obviously getting some ratios, and that ratio will be approaching as you approach in this sequence further. So this ratio is going to be 1.618. Basically, I cannot write it like this because it is actually an irrational number, right? So So this Fibonacci sequence very frequently appears in nature. Continue with this. We have answered this and this. And the why part also I have just explained you that because of the many applications in real life in finance, engineering and physics, it is important to study the sequences. And one particular application which I want to refer because that is connected with what we are doing. It has applications in series, right? Because this chapter is, I told you the name of this chapter is sequence and series. Yeah, I just forgot to tell you this is unit 8. This is chapter 8 of the ninth edition of that book, Thomas and Finney, the sequences and series. So one important usage of studying sequences is in series. अगर हम sequences को अच्छे से नहीं समझेंगे तो हम series नहीं समझ पाएंगे. और series itself, if I'll just give you a very random example, very quick example of a series. So let me take this famous example. Everybody should be already, I think, aware with this. This one, right? So this is an example of an infinite series. This is a particular type of series. इसको हम डिटेल में स्टडी करेंगे जब हम सीरीज पे जाएंगे. It will come as a specific topic there. But right now, since all of you might have known this already, so I have taken this example. This is an infinite series because the terms keep on adding up. The difference between a sequence and series is in sequence the terms are separated by commas like 1, 2, 3, 4, 5. But the same thing if I write 1 plus 2 plus 3 plus 4 plus 5, this will become a series. So this is a sequence, this is a series. तो सीरीज की कन्वर्जेंस डाइवर्जेंस को समझना बहुत जरूरी है. वी वांट टू अंडरस्टैंड वेदर अ सीरीज कन्वर्जेस और डाइवर्जेस. व्हाट एग्जैक्टली इज दैट वो भी हम डिफाइन करेंगे जब हम सीरीज पे जाएंगे. बट दैट इज हैविंग एन इम्पॉर्टेंट मीनिंग, द सीरीज कन्वर्जेंस एंड डाइवर्जेंस. और सीरीज की कन्वर्जेंस डाइवर्जेंस समझने के लिए हमें सीक्वेंस की कन्वर्जेंस डाइवर्जेंस समझना जरूरी है. दैट्स व्हाई मेन चैप्टर यू कैन से इट इज इनफाइनाइट सीरीज, बट बिकॉज सीरीज को समझने के लिए हमें सीक्वेंसेस की जरूरत है, so that's why we are starting with the sequences. You can relate it in this way. So now we'll go for the sequences. हमने define कर दिया sequence को, examples भी कर लिए. Now we will talk about a very important concept which is convergence or divergence of a sequence. तो आपने सीक्वेंस डिफाइन कर लिया, एक सीक्वेंस आपके सामने है, अब उसके साथ क्या करोगे, राइट? द क्वेश्चन कम्स इन अवर माइंड, व्हाट वी आर गोइंग टू डू विद दिस सीक्वेंस, वेदर वी आर गोइंग टू analyze anything about it, we are going to make any remark about it or anything. So this is the fundamental question which we are going to answer in this chapter. इस पूरे यूनिट में एक ही क्वेश्चन है, पूरे चैप्टर सीक्वेंसेस एंड सीरीज में एक ही क्वेश्चन है जिसका आपको आंसर देना है, whether this sequence is convergent or divergent. And the same question will be asked for series, whether this series is convergent or divergent. But sequence की convergence divergence different है series से. So let's just not take the name of the series now. अभी हम पहले sequence पे focus करेंगे कि convergence divergence of a sequence का क्या मतलब है. So for that I'll be starting with an example. I straightforward, I don't want to just give you any definition. So let me just start with the example and let's just first understand the meaning of convergence and divergence, right? So the very first example which I'm going to take is your an is root n, right? Square root n. So this is the way we define a sequence. As I told you, in curly braces, we write the term like that, or even if it is written like this, so it's understood that it is the general term of a sequence. It will be properly explained or mentioned in the question statement that this is nothing but the general term of a sequence. So an is root n. So let's see how this sequence unfolds. So iski one by one हम terms calculate करते हैं and then we'll see that. So most of the times क्या होता है, अब हमें terms लिखनी है इसकी, तो हम कहाँ से start करेंगे? We'll start from n equals to 1. By default, we will always start from n equals to 1, unless or until कुछ mention हो कि 2 से start करो या 3 से start करो, right? बिकॉज इसके डोमेन जो है नेचुरल नंबर्स है. सो अगर कुछ भी मेंशन्ड नहीं है यहाँ पे, कोई इंफॉर्मेशन गिवन नहीं है, एडिशनल सिर्फ इतना ही लिखा है या इतना ही लिखा है, तो डेफिनेटली उसकी टर्म्स बाय डिफॉल्ट हम अज्यूम करेंगे 1 से स्टार्ट हो रही हैं. बट if it is something specific is mentioned like n equals to 3 or n greater than equals to 4 or anything like that, फिर हम वहां से स्टार्ट करेंगे. ओके. Yeah. So this, let's just write the terms of this sequence. So when you put n equals to 1, a1 is square root of 1, which is 1. When you put n equals to 2, a2 is square root of 2. Let's not write their decimal expansions because abhi ke liye we don't need that. I'm just writing them by substituting this. 1 square root 2 square root 3, n equals to 4 will be square root 4, which is 2, and so on. So this way you just keep on writing the terms. So by writing 3 to 4 terms हमें idea हो जाता है sequence की terms कैसे behave कर रही हैं. So let's see a representation now. इनको हम कैसे represent करेंगे, right? So you take a real line because आपका जो n है natural number है, so the natural numbers are obviously the part of the real number. So we draw a real line. यहाँ पे हम sequence के टर्म्स को 1 by 1 मार्क करेंगे, राइट? तो सपोज ये आपका फर्स्ट टर्म कहाँ पे है सीक्वेंस का, a1 is 1. तो सपोज आपने यहाँ पे मार्क कर दिया, दिस इज से 1. So this is your a1. Then the second term a2 is root 2. The magnitude of root 2 is 1.414. तो अगर हम एक स्केल चूज कर लें, अगर इससे ये 0 है, ये 1 है, से ये 2 है, ये 3 है, तो मैंने एक स्केल बना लिया है, एक equally divisions बना ली है रियल लाइन की. I'm just on this real line on equally spaced intervals. I'm going to locate the terms of my sequence. So this is my first term, right? Let's just mark with other pen. This is my first term. Where is the second term? Root 2. Root 2 is 1.414. So it will be somewhere here, right? बहुत roughly मैं आपको mark करना सिखा रही हूँ because एक्चुअल में हम किसी और वे से आइडेंटिफाई करेंगे, बट ये हमें कन्वर्जेंस डाइवर्जेंस समझने के लिए है. एंड देन a3 is root 3 is 1.732, so it will be roughly here, right? a3, and this will be my a4, which is 2, and all of you can anticipate now where will be a5, square root of 5, so that will be beyond this, and then a6, so that means the sequence terms are like a1, a2, a3, a4, they are going in this direction. a1 is less than a2, a2 is less than a3, and so on. That means the next term of the sequence is going to be greater than the previous term. So हमने एक उनमें mathematical relation देख लिया है कि terms of the sequence कैसे connected हैं, वो बड़ी होती जा रही हैं या छोटी होती जा रही हैं, same रह रही हैं या क्या है, right? So that is the identification we have done, that the next term is greater than the previous term. And similar way, you can express the same information in a graph, where on this side you take your domain. So domain we know is the natural number. So ये natural number का notation है, capital N से हम इसको denote करते हैं with a double solid line on this side. So this is capital N. And इस side हम उसको range define करेंगे, because yesterday I told you कि basically sequence is a function जिसकी domain natural numbers है और range उसकी values हैं. So natural numbers means, say this is 1, 2, 3, 4, 5, and so on. On this side we'll be marking the terms. So first term of the sequence is 1. So say this is 1, 2, 3, 4, and so on this side. So the first term is this. Second term is root 2. So the second term will be 1.414 roughly here. So all of us are obviously clear with the fundamentals. Graph कैसे draw करते हैं. Basically the same thing I'm doing. a3 is root 3. So a3 is root 3 will be here. a4 will be 2. a5 will be this. Means we got the trend here, general trend, that it keeps on increasing. In magnitude, there is no way it can come back or it will become constant. Okay. So we just need to look at these values. So these values are going continuously keep on increasing. So this is an example of a diverging sequence, right? डाइवर्जिंग सीक्वेंस, बिकॉज कन्वर्जेंस का मतलब क्या है? कन्वर्जेंस का मतलब है इफ यू आर एबल टू फाइंड अ पर्टिकुलर
Ma'am, can you
पॉइंट
please repeat?
ऑन रियल लाइन, आपको कोई एक नंबर रियल लाइन पे अगर ऐसा मिल गया कि सारी टर्म्स उसी के क्लोज होती जा रही हैं एज द टर्म्स आर इंक्रीजिंग, देन वी से दैट इज कन्वर्जेंट. But if they are just keeping not following any pattern, they are not becoming close to any particular number, they are just moving continuously away from some point, so we call it a diverging sequence, right? So this is continuously keep on increasing, so it is not going to converge somewhere, right? कन्वर्जेंस का मतलब आप ऐसे समझ सकते हो, सपोज देयर इज अ काउंटर, देयर इज अ पर्टिकुलर काउंटर, आप किसी फेस्टिवल में गए हो, किसी फेस्ट में गए हो, वहां पे अलग अलग काउंटर्स हैं, बट एक पर्टिकुलर काउंटर है, सपोज दैट्स एन आइसक्रीम पार्लर, सपोज just take an example, वो आइसक्रीम का काउंटर है, suppose it's very hot, so everybody is just gathering around that
Cold,
counter, maybe
very cold.
because whatever be the reason, right, it is very hot or the ice cream is very famous or whatever,
Ice
but
cream is very cold.
everybody present there in the fest, most of the people, like 80% of the people are gathered around this counter only. So this is that common point where everybody has converged to. So this is the means, in the language of a layman you can understand convergence in this way. आप एक particular reference point के पास बहुत सारी terms of the sequence इकट्ठा होती जा रही हैं, सो हम कहते हैं कि सीक्वेंस उस पॉइंट को कन्वर्ज कर रहा है, राइट? और अगर ऐसा बिहेवियर आपके सीक्वेंस में नहीं है, तो उसको हम बोलते हैं कि वो डाइवर्ज कर रहा है. ओके, सो अगेन आई विल इंटरप्ट समथिंग टू से, ये जो मैं एग्जांपल जिस तरीके से आपको एक्सप्लेन कर रही हूँ, ये सिर्फ कन्वर्जेंस और डाइवर्जेंस का मीनिंग समझने के लिए है. उसके बाद जब हमें मीनिंग क्लियर हो जाएगा, क्वेश्चंस करने के लिए हम मैथमेटिकल फॉर्मूला से करेंगे. सो दिस विल ऑलवेज हैपन इन मोस्ट ऑफ द टॉपिक्स. हमें थ्योरेटिकल अंडरस्टैंडिंग के लिए चीजों को ग्राफिकली विजुलाइज करके समझना है. उसके बाद क्वेश्चन करना बहुत आसान है. क्वेश्चन के लिए आपको हर क्वेश्चन के लिए ऐसे इतना कुछ ये ग्राफिकली ड्राइंग नहीं करनी पड़ेगी. दिस इज जस्ट फॉर अवर बेटर अंडरस्टैंडिंग ऑफ द कॉन्सेप्ट ऑफ कन्वर्जेंस एंड डाइवर्जेंस. So this is an example of diverging sequence because nowhere there is one point जहाँ पे उसकी सारी terms इकट्ठी होती जा रही हैं. अगर आपको अभी भी डाउट है तो वो नेक्स्ट एग्जाम्पल से क्लियर हो जाएंगे. So the next example I'm going to take, say an is 1 by n. So if you now write the terms of this sequence, so a1 is 1, if you put n equals to 1, so a1 is 1. If you put n equals to 2, so you have a2
1 by
is
2.
1 by 2, n equals to 3, a3 is 1 by 3, and you keep on doing that, so you will get to see the terms of the sequence like that. तो इसको भी अगर हम रियल लाइन पे रिप्रेजेंट करें, तो से समवेयर आपने से ये 0 है, से ये आपने 1 मार्क किया है. सो if you mark the terms of the sequence, so the first term is here, so this is my a1. The second term is 1 by 2, which is 0.5, so it's exactly in the middle of this interval 0 to 1. So this is a2 is half. Third term is 1 by 3, so obviously this will be even closer to 0 because 1 by 3 is less than 1 by 2. And then we have 1 by 4, so 1 by 4 will be here, right? So you keep on imagining, ये first term था, ये second था, ये third था, ये fourth था. So by writing these 4 terms, I can very well anticipate where the fifth term is going to be. It's going to be 1 by 5. So 1 by 5 is 0.2. So there will be a5. Then we'll have a6. Then we'll have a7. So it's continuously moving closer to 0, right? But they cannot go beyond this point. You know that. Because an is 1 by n. आप n कितना भी बड़ा से बड़ा ले लो, take n very very large, even if you take say n thousand, so in that case the 1000 term of the sequence is going to be 10 raised to power minus 3, 1 by 1000, so which is 0.001. so it is very close to 0, but obviously वो exactly 0 भी कभी नहीं बनेगा, और नेगेटिव साइड तो वो जा ही नहीं सकता है, because all of these numbers are strictly positive. So this is an example of a convergent sequence, because we have got a number in our sequence, means वो जो limit है जिस number की हम बात कर रहे हैं वो sequence का part हो चाहे नहीं हो. 0 is not a part of our sequence. This is not any term of the sequence. इस सीक्वेंस की कोई भी टर्म एग्जैक्टली जीरो नहीं बनेगी द वे आई हैव एक्सप्लेन्ड यू, बट वी कैन सी द टर्म्स ऑफ दिस सीक्वेंस आर बिकमिंग क्लोजर एंड क्लोजर टुवर्ड्स जीरो. सो बहुत ज्यादा टर्म्स आपकी जो है दे विल बी लाइंग हियर very 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 close to zero. So we will say this sequence is convergent to zero because we have got a number जिसके आसपास सारी टर्म्स इकट्ठी होती जा रही हैं. सारी मीन्स सारी का मतलब होता है इनफाइनाइटली मेनी टर्म्स. फाइनाइटली मेनी टर्म्स उससे दूर भी हैं. अगर आप इसको दूर भी मान लो कि ये 3 टर्म्स को तो मैं जीरो से दूर मान रहा हूँ तो ठीक है, लेट इट बी. बट उसके बाद वाली सारी टर्म्स जो है इनफाइनाइटली मेनी टर्म्स जो है दे आर बिकमिंग क्लोजर एंड क्लोजर टू जीरो. तो ये कन्वर्जेंट सीक्वेंस की अंडरस्टैंडिंग है. इस तरह के सीक्वेंस को हम कन्वर्जेंट सीक्वेंस बोलते हैं, राइट. सो ये सिर्फ आपको कन्वर्जेंस डाइवर्जेंस का मीनिंग समझाने के लिए था. आई जस्ट टेक वन मोर एग्जांपल वेरी क्विकली एंड देन आई टेक योर डाउट्स. थर्ड एग्जांपल इज से an is say 3. Let's take an is 3 means it's a constant sequence. All the terms are 3 3 3 3 3 and so on. ये n पे डिपेंडेंट नहीं है, राइट. इफ यू लुक एट द वेरी फर्स्ट द सेकेंड एग्जाम्पल, ये भी n का फंक्शन था आपकी टर्म, तो n वेरी करने पे उसका मैग्नीट्यूड बदलेगा. ये वाला भी n का फंक्शन था, स्क्वायर रूट ऑफ n, so they were dependent on n. But if your general term is independent of n, whatever be its magnitude, so that's essentially a constant. So this sequence is a constant sequence. So yeah, just let me know whether you just give me the answer of this question, whether this sequence will be a convergent sequence or a divergent. Something कि रियल लाइन पे हमें एक टर्म मिल जाए, कोई भी एक नंबर मिल जाए कि सीक्वेंस की सारी टर्म्स उसी के आसपास हैं, उसी के अराउंड किसी छोटे से इंटरवल में वो कन्वर्ज हो रही हैं. बट यहाँ पे क्या हो रहा है, यहाँ पे तो वो 3 पे ही रह रही है, 3 से वो मूव ही नहीं हुआ सीक्वेंस, राइट. वो दूर गया ही नहीं कि उसको पास आना पड़े, राइट. सो इट्स already at 3, so every term is 3. So this is a default, a trivial example of a convergent sequence. So you remember this, a constant sequence is always convergent. And जब भी आप ये क्वेश्चन का आंसर करते हो कि सीक्वेंस कन्वर्जेंट है, उसके साथ फिर ये भी आंसर करना है कन्वर्जेंट टू व्हाट, उसकी लिमिट क्या है. जिस नंबर को वो कन्वर्ज करता है उसको उसकी लिमिट बोला जाता है. सो इट इज कन्वर्जेंट टू 3, जो उसका मैग्नीट्यूड है. जैसे ये वाला जो सेकंड सीक्वेंस था ये कन्वर्जेंट टू 0 था, पहले वाला कन्वर्जेंट था ही नहीं, वो डाइवर्जेंट था. तो ऑब्वियसली डाइवर्जेंट में लिमिट होती ही नहीं है, तो वहां बताने की जरूरत नहीं है. तो या